Okay, I've been asked about this particular limit, and I thought I'd record a video to add a couple comments regarding it. This particular function is kind of interesting in that there's a nice algebraic trick that we can use to interpret the limit as x approaches infinity or negative infinity. Essentially, what we're going to do here is we're going to divide by a particular term in order to reduce the largest exponent that exists in the denominator, which we see here. Now, what I'm about to do isn't necessarily algebraically equivalent, but it is equivalent in terms of limits. So it's really important that we do carry our limit notation as we go through this particular problem. So the limit of this function as x approaches infinity, what I'm going to do is I'm going to essentially divide by 1, so I'm not going to change the value of this fraction at all. I'm just going to change the way it looks, and instead of using the whole number 1, I'm going to use an interesting fraction. And maybe to make this a little bit more clear, I'm going to choose to multiply by the reciprocal of something. So the something that I'm going to consider here is not just 6x to the fourth, but I'm actually thinking square root of 6x to the fourth, because as I distribute in what I'm about to, in order to kind of account for this limit behavior, the square root of 6x to the fourth is going to be, well, the square root of 6 times x squared. So this is what I'm going to multiply in. I'm going to multiply 1 over x squared in the numerator and 1 over x squared into the denominator. So here again, we're not saying that this is algebraically appropriate, but in terms of describing the behavior of the function, also known as its limit, this is okay to do. So in the numerator, I'm going to take this 1 over x squared. I'm essentially going to distribute it into this fraction here, I'm sorry, into this radical here. And then in the denominator, I'm also going to distribute this 1 over x squared into every term. And in a sense, what we end up with is the limit as x approaches infinity of the cube root of x to the sixth over x to the sixth plus 64 over x to the sixth, all divided by 2x squared over x squared plus the square root of 6x to the fourth over x to the fourth plus 1 over x to the fourth. Now this may seem a bit confusing because I was talking about multiplying in x squared, but keep in mind that it's the cube root of 1 over x to the sixth, cube root of 1 over x to the sixth, that is equivalent to 1 over x squared. And down here, it's the square root of 1 over x to the fourth that's equivalent to 1 over x squared. So if our goal was to multiply in 1 over x squared, we represent it by the square root of 1 over x to the fourth, or the cube root of 1 over x to the sixth. So how is this trick particularly helpful? Well, when it comes to limit behavior, we should start to notice something that's occurring here with this x to the sixth over x to the sixth and 6x to the fourth over x to the fourth, as well as some constant over a polynomial and another constant over a polynomial. So as it turns out, the limit as x approaches infinity now is the cube root of 1 plus 64 over x to the sixth. We have 2 plus the square root of 6 plus 1 over x to the fourth. And now we can kind of interpret this limit as we talked about on Thursday when a few of you stopped by the classroom. We don't particularly have a way to directly substitute or further analyze this, but we can kind of imagine what's happening here. As this x to the sixth, as x approaches infinity, this component itself blows up towards infinity, and same thing over here. Now we had said that any constant divided by an extremely large value tends towards, so altogether this fraction is going to tend tend towards 0, and similarly down here, this will tend towards 0 as x approaches infinity. So with that preliminary understanding, I'm happy in stating that the limit as x approaches infinity would simply be the cube root of 1 plus 0 over 2 plus the square root of 6. Now clearly the cube root of 1 is 1, so I think I would be comfortable in stating that the limit that this function approaches is 1 over 2 plus the square root of 6. Now to answer the second part of the question, the limit as x approaches negative infinity, I would consider much the same approach and think about what happens as x approaches negative infinity in this case. All the preliminary work remains the same, and I'll ask you to consider what happens as x gets larger and larger, as x gets smaller and smaller as it approaches negative infinity. What's going to happen to this limit, and therefore what might happen to this component as we consider the limits. And I'll leave that to you to finish up. Hopefully this helps. Thanks for watching.